Hello everybody. Today we're going to do Unit 5, free response questions 1, 2, 3, and 4, all on different videos. So this first one, we're given a function f of x equals 2x times e to the negative x. And the first part is we want to know where, on what intervals the function is increasing. Now, this would be a no calculator question if we were taking the test normally. You obviously can use your calculator to see what this graph looks like, and you can see where it is increasing. However, you won't get any credit on the AP exam for just looking at the graph and telling you have to show calculus to get credit. And so using calculus, if we want to know where a function is increasing or decreasing, we first find the derivative. And when you find the derivative on this particular function, we're going to need to use the product rule. So I will leave the first part alone and multiply by the derivative of the second. Now when we find the derivative of e to the negative x, we have to do the chain rule. So it's going to be e to the negative x, and then we multiply by the derivative of the exponent. So the derivative of negative x is -1. Right, and then plus, we're going to leave the second one alone and multiply by the derivative of the first. Okay, and then I'll clean this up a little bit. Right, and so when we're looking at the derivative to determine where a function is increasing, we want to know when the derivative is positive. But to set up our sign chart, we need to know when the derivative is negative. We need to know the critical numbers. So just to make this a little easier for us, I'm going to factor a common factor out. So I'm going to factor out -2 e to the negative x and set that equal to 0. All right, so -2 e to the negative x is never going to be 0. But x minus 1 is going to be 0 when x is equal to 1. So what we would do is draw our number line. We are not given an interval on this problem, so it's going to keep going in both directions. We'll put our critical number in the middle, and then we're going to test points on each side, and when we're testing them in the derivative. So I'm going to plug in 0, and I'm going to plug in 2. And again, we really only need to know when, if we get positive or negative. But you guys also have a calculator, so you can just plug it in the calculator. So when I put in 0, I'm going to get -2 times -1, which is going to be a positive. All right, and then when I plug in 2, I'm going to get negative something times 1, which is going to be a negative. Now, a sign chart is good to show your work, but the AP readers will not accept sign charts as justification. So you need to explain why you say what you say using the sign chart. So your answer should be f of x is increasing on the interval from -∞ to 1 because f prime of x is positive there. Okay. The next question, we have the same function, and it tells you at x equals 1, f prime of x is 0. And then they want us to tell them, oh, we already knew that because we just found that, but that's okay. And then they want us to tell them if f has a relative minimum or a relative maximum or neither at x equals 1. And then we're going to justify our answer. So we already did that sign chart. I'm just going to go ahead and draw it so I don't have to scroll up and down. Okay, so we know that at 1, the derivative is 0. So that's a critical number. Possibly a maximum or minimum, but it could be neither. So I know that to the right of 1, the function is increasing. And to the left of 1, the function is decreasing. So that is going to result in a relative maximum. And so this is not a good enough justification. So what you would say is f of x has a relative maximum at x equals 1 because f prime of x changes from positive to negative. And that's good. On maximum and minimum, we cannot say changes sign. We do have to be specific about if it changes from positive to negative or negative to positive, because if f prime changed from negative to positive, that would create a relative minimum. And again, make sure you don't say it, because there are several different things that could be it here. You have to be specific about what you're talking about. All right, so for C, does the graph of f have a point of inflection at 2, x equals 2, and we need to give a reason. So to find points of inflection, we need the second derivative. So I'm just going to write down the first derivative real quick. I'm going to use the factored version. It actually doesn't really matter. I think this might be somewhat easier. Okay, so we're going to do the product rule, where we'll find the derivative of 2e. Sorry, we're going to leave negative 2e to the negative x alone and multiply by the derivative of x minus 1, which is 1. Plus, leave x minus 1 alone, multiply by the derivative of negative 2e to the negative x. So it's going to be negative 2e to the negative x, but then we have to multiply by the derivative of negative x, which is negative 1. Okay, so I have a little bit of cleaning up to do. Now, if this was just find the second derivative, you could stop right there. You can leave it super messy. But because I have to use this, I'm going to want to clean it up a little bit. So negative 2 times negative 1 is going to be positive 2. All right, so again, we have a common factor of 2e to the negative x. So let's factor that out. Okay, and when we do, from this first part, we are left with negative 1. And then from the second part, we are left with x minus 1. So that is going to leave you with x minus 2 in the parentheses. All right, so we want to find when this is 0. And that's going to be when x is 2. Oops. Okay, so we'll do another sign chart, but with 2 labeled. And so we're going to test numbers in the second derivative. So we could test any number on the left side of 2 and any number on the right side of 2. I just picked 0 because 0 is typically the easiest number to plug in. So when I put in 0, and again, you can just type this straight in your calculator, but we are going to get, we're going to get 2 times negative 2, which is a negative. I wrote 1 times negative 2 on the paper, which is not right. But it's negative there, and then when I plug 3 in, I'm going to get a positive. And again, that is acceptable work to show, but not acceptable justification to show. So we are going to need to write a statement about the second derivative and about whether or not 2 is a critical number. So because the second derivative changes sign at 2, then f has an point of inflection at x equals 2. So f double prime changes from negative to positive at x equals 2. Therefore, f has an inflection point or a point of inflection. I don't know why I want to say that wrong. Crap. Sorry. At x equals 2. Okay. And then the last part on this one, we're asked to determine if f has any horizontal asymptotes. So whenever you're using calculus to show horizontal asymptotes, you're finding the limit as x approaches infinity. That's the horizontal asymptote going to the right. And we do need to check the left also. So let's just start with the right. So 2x e to the negative x is the same as 2x over e to the x. So that's what we're going to use to find this limit. Now, if I take infinity and I plug in to our x's, that results with infinity over infinity. And when we get that, we get 0 over 0 or infinity over infinity, we can use L'Hopital's rule. And go ahead and find the derivative of the numerator and the denominator. So the derivative of the numerator is 2. The derivative of the denominator is e to the x. So now when I put infinity in for our x, I get 2 over infinity, and 2 over infinity is 0. And again, if you're using your calculator, you know the answer before you start the problem. And you do have to show calculus to get credit, but you at least know if you're right. So what we would say is, okay. I'm going to have to type it because my pen quit working. So we're going to say the graph of f has a horizontal asymptote at y equals 0. Okay, now we also need to check, I think the battery, and I need to charge my pen, but we also need to check the the left side. So I can't write it, but hopefully you guys, hopefully you guys will just look back at my notes where I posted the answers, because I don't want to start this video over because I'm at the very end. But anyway, when we check for the limit as x approaches negative infinity, we do the same thing with L'Hopital's rule. But when we get to this point right here and what's underneath the top line, when we put in negative infinity for x, the negative exponent would move the e to the negative infinity to the top and make it e to the positive infinity. And when you take the limit and you get infinity, there is no horizontal